Right. Hello, everybody. How is everybody doing? I'm just now allowing everybody to enter the call. So just making sure that connection's looking good. And as usual, when Zoom allows people in, I understand some people had some difficulty this time around, so that's why some of you guys may have had a separate invitation sent on multiple occasions, so I can only apologise about that. I just wanted to make sure that as many of you guys could join in this call as possible. So it's lovely to see you guys streaming on in, lovely to meet some new faces in the mix as well. So I thoroughly appreciate your time in coming to join with me for this special event, which we'll be discussing about deep sky objects. So as usual, guys, if you guys have done this before, the usual protocol is I leave it about 5 minutes just to gradually allow more members to join in, just in case they're late, just to give everyone a fair chance. And then afterwards, what we'll do is then just go for a bit of briefing on a couple of house rules for this evening's session. And then we will go into the main event itself. So luckily, it looks like everybody's coming in fine, which is good. So there's some new faces and some old ones as well. So I just want to say hello to everybody. So just in case none of you are aware, my name's Josh Jory, and I'm the founder of the astronomy organization Space4All. Here's the badge, and also in the background as well. It's quite difficult to do this on a virtual background, but hey. And my mission is literally to engage practical astronomy and also to engage members from all backgrounds, because for members who are new to the group or have shown an interest for Space4All, I've seen a dramatic interest for practical astronomy and stargazing. Now, for somebody, I'm an astronomer, right, who's 23 years old, and that's how I got into astronomy. And I personally believe starting at the basics is the way that we can get interested in the stars and beyond. So that's what I'm hoping to achieve in this series of virtual events to keep us connected to the stars during lockdown or various COVID implications as of yet, hence why we're meeting virtually. And if government guidance permits, hopefully we can then meet in person. I'm hoping from about mid-end, so that second half of the year, if we're lucky enough. But again, all of that's due to change. I'm sure you guys can understand. So we've got 2 more minutes. I will give people a chance just in case they're late, whilst I'm going to take a sip of cup of tea out of my astronomical mug for the occasion.
Oh, nice one.
Thank you, Sue. I heard you there. Muting, guys, just for the second, but it's only when we start into the actual presentation that I'll ask everyone to mute themselves, just so that's fair for everybody. So last time, guys, we were discussing International Dark Sky Week, and then what I'm doing then and what the International Dark Sky Association is doing to protect dark skies. So if anybody has any questions or any thoughts since our last virtual workshop, please don't hesitate to get in touch. Like, if I've purposefully got the chat tool sorted, so if you've got any questions whatsoever, please make sure to use it throughout. I'm here to use my knowledge at your guys' disposal, and hopefully we'll be in for an hours of entertainment with Space4All anyway, so it'd be a good bit of fun. So guys, I think I'm going to crack on with the presentation now, actually, because we're nearing 5 minutes past, and I appreciate all you guys spending your time to be here with me. So I will begin by going into the presentation itself. So bear with me 2 seconds as I get this set up. Just to confirm, everybody, I can see you on the corner of my screen now. Can I just have a thumbs up just to confirm you can all hear me? Fantastic, lovely. Check that, because you never know what technology is going to throw at you, so I always like to double check that one. Right, okay, so if I can just get this into interview here as it loads up, and put you guys in the corner of the screen so I can see all your lovely faces. Right, I think we're ready to begin. So just to confirm, so that we're on a good track for this evening, can everybody see a picture of the Space4All logo at the bottom of their screens? Because if so, that's perfect. And I just got a few more things yet to sort out just before we begin. Just give me 2 seconds, guys. And I'm also going to, if I can, record the session too. So we're going to record here. Okay, so we're recording now as well, which is great. Okay, guys, we're ready to go. Okay, so just for any new members who are just coming in, I'd just like to say thank you very much for joining me for my next virtual astronomy workshop with Space4All. And in this session today, we're going to be looking at deep sky objects. So we're going to be looking at the amazing wonders of the night sky, whether that be galaxies, nebulas, and star clusters. So just a bit of housekeeping, guys, just so that it's fair for everybody and so that everyone can have an enjoyable time this evening. Please may everybody mute themselves now before the workshop begins so that I can deliver as quick a presentation as possible for you guys. If you guys have any questions, please use the chat tool, and just at the beginning, if you can for me, just put the word question just so that I can highlight those through the chat if need be. And otherwise, if anyone wants to ask a question throughout, please use the raise your hand tool, which is also, it should be in the bottom of your sidebar for you if you want to ask any questions throughout. Otherwise, I'm happy to deliver those Q&A sessions at the very end, just in case anybody wants to know that. So let's just move on to the next slide. Okay then, so what are my ambitions with Space4All? So as I mentioned earlier, Space4All is there to actively promote practical astronomy and to engage members from all backgrounds. So the reason I set up this astronomy organization is because I purely want to engage members with things like how to set up their telescopes, how do I identify the constellations, planets, deep sky objects, so on. Because I believe starting at the basic levels is what will gradually gain people's interest into the night sky and beyond. So another reason as well is to realize how under threat the night sky is now more than ever because of the impacts of light pollution and satellite constellations, which we have seen in recent years. And most importantly, as has been demonstrated by the past year, is how the night sky has kept us connected during lockdown, during these uncertain times. So it's another incorporated element to tonight's talk. Right then, so deep sky objects, the wonders of the universe, from galaxies, nebulas, and star clusters. What are we going to see today? I've just made a couple of notes as well, just to help me. So if there's any pauses, please bear with me on this. So this photograph here is just a quick image that I captured of a part of the Milky Way galaxy. Now, in our narrative this evening, as we travel away from light pollution, from our inner towns and cities, and we go out to a truly dark sky, we see the Milky Way as it passes overhead. And as we look up to the night sky on a clear night, we can see hundreds, if not billions, of stars. And in doing so, we can see the glowing gas clouds of where stars are being born, but we can also see vast balls of ancient stars. We can see the star clusters in our night sky. But as we look beyond the Milky Way, we see countless galaxies which stretch millions, if not billions, of light years away. And in galaxy formation, we can see galaxies to the very early beginnings of our universe. So much so, we can see galaxies which have formed with one another. We can see coalesced gas of dust and gas forming these clouds, which we now know as nebulas. But also at the same time, the universe tells us so much about astronomy in terms of our perception of the universe and the age of light, and how when we use telescopes in our next advanced level into astronomy, we can resolve this ancient fragile starlight and explore the universe to the depths and beyond. So in this first section then, we're going to be talking about galaxies, the really exciting ones in my personal opinion. Why? Because there are some galaxies which are so striking in appearance, but even though we got like spiral galaxies, for example, we get different types. So I'm going to go through those with you just to understand exactly what these different types are. So At the very beginning of the universe, we saw some very elliptical-like galaxies. So these have been distorted through space-time and through the depths of time itself and the expansion of our universe. But it's also interesting to note that with these galaxies, which are known as elliptical galaxies, that there are no spiral arms. So they are devoid of gas and dust. And so they are home to some of the oldest stars in the universe and is elliptical in shape. So it's a very almost symmetrical like shape, which we can see in this image. For those of you who are more advanced in astronomy, I've also included the name of some of these deep sky objects here for you. For 1 minute, I do not expect any beginners to understand this. I tell you, when I started out, when I was 7 years old, all this blew over my head, so I can understand if it's the same for you guys. But just for those of you who are a bit more advanced, this particular elliptical galaxy called ESO 325-G004 is a very well-defined elliptical galaxy, and there has been some heavy astronomical research on this subject, but is also a prime example for understanding just exactly what defines an elliptical galaxy. So we can understand what that definition means now. We also get lenticular galaxies. For me, I love these objects because, lenticular is basically the term of trying to observe a dust lane in front of a bright nucleus. But I'll go through my notes just to aid me in this. So lenticular galaxies are roughly spherical. So they are a disk of stars and gas around a nucleus, and this is made up of older stars. Disks are very much like spiral galaxies in that sense, but there are no spiral arms necessarily, and can also observe regions of star formation. So there's some examples of galaxies I can tell you about, such as the Sombrero Galaxy, for example, and we can observe these galaxies edge on. So we can see the dark matter which clusters the spiral arms of these galaxies. And there's one good example, which I've just highlighted on my screen here, which is Messier Object 102, for those of you who are interested, and is also catalogued as NGC 5866, which is also known as the Spindle Galaxy. And these are some really beautiful objects to look through a telescope, especially when you do some long exposure astrophotography, because I just love the perspective of these objects. The fact that we can see them side on, we can see the brightness of these nucleus, or the nucleuses, in fact, emerging through this fragile dust and light is such a lovely contrast to observe through a telescope and through imaging as well. So these are some very exciting ones, colliding galaxies. So what exactly are these types of galaxies? So this is when more than one galaxy is merging with another. So they can create bizarre shapes. So usually this can be through interacting galaxies, which are influenced through gravitational pull, and in doing so twist and deform each other. So it's like a galactic sort of fight going on with one another, as one realm of gravity is fighting with another, and this material is being, if not sometimes, torn apart and ejected off into space. And as I mentioned, this material can be thrown out from collisions. You've only got to see this image here of what is known as NGC 4676, A and B, for those of you who are interested. And these are known as the mice galaxies. And I love these objects because you have to use a bit of artistic interpretation here, but especially if you image these galaxies, you can understand by their long tails, which you can see in examples of astro imaging anyway, it takes on this name of the mice galaxy. So two groupings of galaxies which just happen to be merging with one another at this moment in time. Now, for those of you who know more a bit about the night sky, and which we'll cover in just a second actually, there's one deep sky object which I'll be telling you about, which is known as the Andromeda Galaxy, known as M31. I'll cover this in just a second, but in fact, it's coming towards Earth. Now, astronomical research suggests because it's coming towards our Milky Way galaxy, in a number of million of years' time, this galaxy will eventually collide with the Milky Way. So don't worry, guys, we would have seen our lifetimes through at that moment in time, but in the very long distant future, our galaxy and the Andromeda Galaxy will suffer the same fate as these galaxies, which you can see on your computer screens. So already, you know, there's so much to observe in the night sky, and it's countless. You've already got to see, and to give you a perspective of the universe, this is what amazes me as an astronomer. In this picture here, you can see loads and loads of distant galaxies. And when you measure the light, or when professional astronomers observe the light of these fragile galaxies in the depths of the universe, we can understand how far away these objects are from Earth. So I've also got some handouts just to omit later in this presentation, which highlight some examples of objects you can see and how far away they are in space. But I'll go into discussion about that as the night goes on. But it's just amazing to think, really, what are you looking at here? How has time influenced what you have seen in the night sky? And are we actually seeing the mirror images of what we're seeing today? There's a little catch there for you this evening. So there's also irregular galaxies. When you guys see this image, does it look like the galaxies that we've seen so far during our astronomical journey? I think it's fair to say not really, although some of you may argue that and say, well, actually, yes, it does. And I'll tell you why. Because irregular galaxies are those with no clear form. So we see the likes of spiral galaxies, for example, and they've got a clearly defined structure where we can see the spiral arms within the structure of the galaxy itself, right? But when we see irregular galaxies, this isn't the case. And so these galaxies are much more rich in star clusters, as you can see in this image of an object called NGC 1427A. These bright spots of light, which you can see in this image, are clearly defined star clusters, which are compounded together in a very dense region of star activity. So also, they come in many different shapes and sizes of universal features, which are the result of interaction with other galaxies. So this can suggest to us why these deep sky objects aren't very clear in their structural form, because it can be to suggest that they have had some gravitational influence by other celestial objects in the past, so hence why they take on such an irregular form. But there's some beautiful objects to look at, and if you've been lucky enough to go to the southern hemisphere to see them, I've had that privilege only once, but it was beautiful to see, are the likes of the large and the small Magellanic Clouds. And when you see these objects in the night sky, you know, they are part of the Milky Way galaxy, but you look at these very irregular like forms and you study these objects with telescopes, and they are so rich and vivid with celestial features which we can see because they're so compound with matter like gas and dust, which eventually forms star forming regions. And in astro imaging anyway, we can see some very interesting details through color and wavelengths of light. So I'll now move on to the next slide. Spiral Galaxy. So this is what I've eventually been waiting to get onto. So these are the most iconic and most recognized beautiful celestial swirls which we can see in the night sky. So they compound of a very strong central nucleus which is composed of older stars, surrounded by a flat disk of stars, gas and dust. Spiral arms contain young and bright stars and star forming regions in the form of nebulae. So if you can, guys, just try skimming this image, and I'll just highlight a couple of those here for you now using my mouse, where you can see examples of nebulosity. Whilst I'm just telling you this, try and look at this image and spot some of these features for yourself. But this spiral shape is influenced by a density wave. This is what creates this iconic spiral effect which we see, which travels around the disk of gas and dust and triggers the birth of new stars. So we can see these star-forming regions. And in this example is one of my personal favorites, which is the Messier object 101, which is known as the Pinwheel Galaxy, and has been given that term because it's got such a strong spiral shape. And there's so many objects which we can see, and I'll also highlight tonight, which are further examples of spiral galaxies. Right then, so those are some what I'd say more sophisticated deep sky objects to see. But for those of you who are the beginner into astronomy, what are some examples of galaxies you can observe with your unaided eyes, but if you fancy it, the likes of optical aids, binoculars and telescopes? So this is what I was mentioning earlier, the Andromeda Galaxy, also known as M31 in Charles Messier's list of deep sky objects. This celestial object was one of the first deep sky objects that I personally observed back when I was 7 years old. And this particular deep sky object is located in the constellation of Andromeda, which is near to the constellations Cassiopeia and Pegasus. And when you train your eyes and even optical instruments on this deep sky object, you can see a faint ball of light. Now, it's interesting because all of this is formed, as I've mentioned earlier, by this fragile starlight formed of much older stars. So it is the most impressive and easy to see galaxy, in my personal opinion, in the Northern Hemisphere, which is located, right, you try and get your head around this, 2.5 million light years from Earth. I love telling my audiences about this because when you look at the fragile starlight, which is emanating from M31, that light has taken a light journey through space for 2.5 million years, which means we are technically seeing an image of an object as it was then. So we're not, strictly speaking, seeing objects at the very instant we look at them, which almost provokes the idea of what do these objects look like and are they actually there? So what's to say? All which can aid us is really the likes of professional astronomical research and how we study this faint fragile starlight. So just for a bit of contextual research then, the Andromeda Galaxy is slightly larger than our own Milky Way galaxy. It's one of the most distant objects which is visible with the unaided eye, and as I've mentioned as well, is one of the objects which we can see without optical instruments such as telescopes and binoculars. So for the beginner, this is an ideal target to see. And don't be alarmed if you're thinking, hold on, Josh, you haven't told me where this object is yet. I have some handouts, which I've mentioned earlier, which I'm happy to show you guys at the end and also send to you across in email if you would be interested. So don't worry, I have all that information waiting for you at the very end. So yes, as I've mentioned, appears as an ellipse of light, which has been dissipated by two smaller patches, which is known as M32, M32 and M110. These are two other galaxies which can be seen in the region of M31. So we can see quite a lot in a small field of view. Okay then, so the Whirlpool Galaxy, this is another iconic deep sky object which we can see. It's a spiral galaxy which is 23 million light years from Earth, a mind-boggling mass, but is located in the constellation of Canes Vanessae and is a magnitude of 8.4. So realistically, to observe this celestial object, you want to be using telescopes, guys. So this is why I'm encouraging you guys more so now to start looking away from objects with your unaided eyes and consider using beginner equipment such as smaller telescopes or a pair of binoculars. So really, what's interesting to note about this deep sky object is the fact that it's face on to us. So we can clearly see the nucleus at the center of this galaxy, and we can see the spiral arms which are stretching out from it. So we really get a unique sense of perspective as we identify the Whirlpool Galaxy. Now, just as I quickly have a quick cup of tea to keep my mouth moist, try and have a look for some of this nebulosity, which you can see in the spiral arms here. And these are some of the star-forming regions, as I've mentioned, through the tides, which create this inevitable spiral-like shape. We can also see the Whirlpool Galaxy interacting with another nearby galaxy. So already in terms of the astrophysics, which is going on here, which I won't go into discussion about tonight, just to say, but from a visual point of view, there's so much interaction going on with these ancient celestial objects. The Cigar Galaxy. Now, don't get me wrong here, but this is literally the astronomical term given to this object, M82, known as the Cigar Galaxy. So this object is located 12 million light years from Earth, located in the constellation of Ursa Major, and M81, which is another celestial object, can also be seen within the same field of view. Now, the reason I selected this one is because there's a very interesting feature which can be observed in the Cigar Galaxy, which are called, right, bear with me on this, Titanic Tendrils. What are Titanic Tendrils, for God's sake? Well, these objects are basically gas and dust being emitted from the center of the nucleus. So as you can see in the Cigar Galaxy, this red debris is basically this material being ejected from the center of this particular galaxy's nucleus, and makes for a very stunning visual display when observed from much larger telescopes, but also the Hubble Space Telescope from NASA. The Triangulum Galaxy, this is another beautiful spiral galaxy, which we can see in the constellation of Triangulum. And I would like to just mention this because, you know, astronomers can report so many different things with deep sky objects. But I personally recommend for the Triangulum Galaxy to observe this object from a truly dark sky site. The reason why purely, you know, with galaxies, guys, as I'm sure you can understand, its light is so fragile. And when you observe these objects from a dark sky place, you can clearly see these defined areas of light as they pass through the constellations. And when you set a telescope on them, my goodness, the view is absolutely stunning. So just to highlight on this particular deep sky object, it's located 2.8 million light years from Earth, and for a small telescope, it can be resolved as a small patch of light. As I've mentioned, in the constellation of Triangulum, and as you can see, like with the Whirlpool Galaxies, you can identify loads of areas of star-forming regions where material is forming stellar nurseries, effectively, where stars are being born and is eventually being formed in the spiral arms, as we've seen in previous examples of galaxies we've covered so far. So we have covered the basics of galaxies. So now we're going to continue our celestial quest into the realm of nebulas, on some of my personal favorites here. So this example, which I'm highlighting to you now, is basic. What are nebulas? I'll highlight this for you now. So it's an area in space which is permeated by gas and dust. And so in some more dense areas in space, vast gas and dust clouds are formed to be known as nebula. So they're influenced by tidal waves, which eventually form stellar fusion, which effectively creates the birth of stars. And we can see some beautiful color arrays from the gas which is being injected. So just to highlight some examples here, this is one type of nebula, which is known as an emission nebula. So I'll just tell you what that is now. So stars are born in clouds of dust and gas generated by a stellar wind, right? So in doing so, carves out caverns within these nebulas and gives them these unique, distinct shapes. And the radiation excites this interstellar gas, to which then generates light. And this is what is effectively an emission nebula. So this what makes them so easy to observe, because light is reflected off of this gas and dust and can be observed with the unaided eye and, more importantly, with optical instruments, which is the case for this particular deep sky object, which is known as the Heart Nebula. So it's a lovely object to show to anybody on Valentine's Day, for example. The reason why is because you can see this slightly irregular love heart shape. So this is why astronomers give or coin this term this, because it looks like the shape of a love heart, hence the Heart Nebula. So in this instance, if I can just drag that from my screen, it's got the designation IC 1805, just for the more, advanced astronomers who are interested. And for this object, I personally recommend a pretty moderate sized telescope, I would say. Honestly, larger than 6 to 8 inches in diameter. It's all to do with the gathering of light, and so you'll be able to see very faint wisps which make up the Heart Nebula. But you'll be able to see much more detail when you focus this light through astrophotography and you gather this fragile starlight when you take long exposures, and only then you can really reveal this sophisticated detail. Okay then, so just moving on, we have reflection nebula. So what is this ghostly image that we have on our screens? So this is light, which is scattered by nearby stars through gas and dust, as we've mentioned previously. And this light in particular scatters at blue color wavelength, so at the more blue end of the spectrum. So this allows us to observe some very interesting carves and caverns within particular reflection nebulas. And in particular, this one really enticed me, which is known as the Keyhole Nebula. So if you can use a bit of imagination here, you can clearly see that it defines what seems to resolve a keyhole, which is identified in the NGC catalogue as NGC 1999. But again, I'll just reiterate, guys, for the likes of this sort of object, you'll really want quite an advanced telescope. So this is what the likes of the Hubble Space Telescope have been able to capture. But we can see some examples of reflection nebula as we go along, which I'll just cover in the next couple of slides. But before we do that, we see examples of dark nebula, right? So this is dense billowing gas, which is, well, it's not emitted from light. So basically they're dense regions in space. So much so, this dark matter is so dense that we can't even see the backdrop of the stars in the background, which is the case for this object, which is the Black River Nebula. And so this nebula appears basically to silhouette against its stellar backdrop. And so effectively, as we can see in forms of reflection nebula, some of the light of nearby stars is being reflected onto this matter, as we can see in these examples here. That's a star cluster, by the way, just to point that one out. But look at this, through some beautiful long exposure astrophotography, we really get a sense of what I mean here in terms of dark nebulas and reflection nebulas as well. It's some really stunning stuff to see. But this is like literally my favorite now. I love planetary nebulas. So the reason what these are basically are the remnants of supernova. So this is when a star has gone under supernova, it's gone towards the end of its life, and it's basically what makes up the stellar makeup of that given star. So as it's exploded, we can see the shell of that star dissipate into space. And just going through my notes here, you can see the stellar core at the center of these nebulas. So we can see these hot, bright fusion stars, which are effectively where all of this material has been ejected from. And this is caused by nuclear fusion, to which we can see this reflected light's being dissipated, as we can see here in the Helix Nebula, designated as NGC 7293. But what's very interesting, because some of you may say, well, Josh, what are you on about? This isn't a planetary object, so why are you calling it a planetary nebula? Now, the reason for this is it was once thought that these nebulas looked like planets by ancient astronomers, but also more recent ones as well, and hence why they adopted the name Planetary Nebula. So when you see these objects and you see the material which has been dissipated into space, we can see some truly stunning formations here, and I think you guys can agree with me there too. But what I'm going to show you now then is some nebulas which you can observe also with your unaided eyes and even your telescopes. So I'm pretty sure that for the more advanced astronomers, you know what I'm going to say. You have to look at the Orion Nebula, which is designated as M42 in Charles Messier's list of deep sky objects. So just to make a couple of notes as well, just in case, it's one of the most easy and interesting nebula to observe, in my personal opinion. So it's located in the constellation of Orion. So you have Orion's belt, and just beneath it is the location of its sword. And when you scan this area, as you can see on these handouts at the end of this presentation, you can see a slightly soft fuzzy patch. And when you turn your telescopes onto these objects, you can see this, this clearly defined coalesced detail, which has been shaped and caverned in these nebulas, such as the Orion Nebula. And just as I've mentioned as well, this particular nebula is a star-forming region. It's where stars are being born, right at the heart of this nebula. And this particular object, which I'm just highlighting here with my mouse, is what's known as the Trapezium Cluster. And these are some examples of some very young, very bright stars, which are just beginning their lives at the center of this nebula. And in doing so, this material is also being injected out, to which we can see this beautiful array of colors being emitted by certain gases and dust. Also to note, this object lies at 1,350 light years from Earth. So in terms of the other celestial objects we've seen so far tonight, this object is actually a bit closer to Earth compared to some of the other celestial bodies, but is also, as I've mentioned, a naked eye target, which I personally recommend seeing from a dark sky site, but you can also use it and observe with your telescopes and see some fascinating detail. So much so I've used some, quite big telescopes up here on the Mendips in Somerset. And when you use larger instruments, you can actually begin to resolve some of this color. And that's quite stunning as well. But through long exposure astro images, here's an example on your screen. The view is purely stunning. So we've now got the Crab Nebula. So this is another really interesting object to see, which is catalogued as M1 and takes on this slightly bizarre shape, which I think is fair enough to say, which resembles the shape which is of a body of a crab. So the actual history of this object doesn't go back to crabs themselves, but in fact goes back to this object being the remnants of, again, a supernova. So it's effectively a supernova remnant. And it was recorded by Chinese astronomers in the year 1054 that they could see this, what was eventually a star exploding. They could see a supernova in the night sky. So much so, it was so bright that in the time it was observed in 1054, this particular supernova could be observed in daylight. So it was effectively, on par with the same magnitude as the sun. How cool is that? We haven't seen one as of yet in our generations. Well, we never know. It might be fair to say there, but a fascinating object to see, because you can see so much stellar structure going on here. So from where all of this material is being ejected off into space, it's undergone fusion from the stellar winds, and we can see this very striking object here on our computer screens. But just to mention as well, it is a stellar skeleton at the end of the day, so it is the remnants of this supernova located in the constellation of Taurus. And really, I personally recommend this is an object best suited to larger telescopes. I've seen some quite good views through telescopes which are 8 inches or larger, sorry. So really, you know, to try and train on this fragile starlight, I'd personally recommend using larger optical equipment if you're going to try it. So one of my other lovely objects, which I love to look at, is the Ring Nebula. So this is a stunning object to see, one of the finest planetary nebulas we can see here in the Northern Hemisphere, and is located 2,300 light years away. And again, it's a shell similar to, well, it was a star similar to that of our sun. But again, it's the same principle as with the Helix Nebula. We see this material being ejected off, and we can see how that light is interacting with this object through stellar winds, and we can observe some of the color signatures from it. So we can identify what gases were basically made up the structure of this far distant star. Right then, so we're now going to look into another series of objects called star clusters. Now, just before I show these series of images, the best way I like to describe star clusters is if you imagine a piece of black paper or card, and if you were to sprinkle salt onto the black card, that is the kind of visual appearance you'll get with star clusters. Can you see what I mean? So, you know, they're quite interesting objects to see, but that's how I like to give a vague description to somebody who's never seen a star cluster before. But just to reiterate then, what are star clusters? Star clusters are of all shapes and sizes found throughout, in this instance, the Milky Way galaxy. And there's two different types of star clusters to which we can see globular clusters and open globular clusters. So I'll just go on throughout, but basically globular clusters are vast spheres of thousands, if not millions, of stars. So they're some of the oldest objects in the galaxy, and these stars can be as old as 12 billion years old. So that's some very fragile starlight which we're looking at. So much so that there is 150 globular clusters scattered around the disk of the Milky Way, and some of those which we are fortunate to observe from here in the Northern Hemisphere, but there's also some stunning objects to observe in the Southern Hemisphere too, such as this object known as the Omega Star Cluster, catalogued NGC 5139. Now, I say Southern Hemisphere objects, but you can see this celestial object from the Northern Hemisphere, but it appears so low on the horizon that you have to look through thick layers of our atmosphere. So really, if you're to observe objects like the Omega Star Cluster, you want to be looking in the Southern Hemisphere, unfortunately, but there are more. So we have this particular cluster. So Glottamy star cluster is an example of an open star cluster. So this is catalogued as M7, just to note that. But basically, it's the opposite of a globular star cluster, where it's a much looser region of stars formed in nebulous cloud and dust. And after stars materialize out of a star-forming area, they eventually dissipate away this gas and dust, which leaves these slightly loose entwined areas in space. So that's effectively what an open star cluster is, folks. So here we go. Here are some examples which I can personally recommend for you to observe. So one of the most iconic ones, which I think everyone will agree with here, is the Pleiades star cluster, which is also identified as M45. One of the most famous star clusters of its kind. It's also known as the Seven Sisters, and is located quite a distance away, I believe here 440 light years away from Earth, located in the constellation of Taurus. And if you've seen it already, it can be observed with the naked eye. So it's a brilliant object to see, but is also, which is really interesting to note as well, it's a form of reflection nebula, guys. So 10 brownie points if you've got that one, because the light of these stars is being emitted against background gas and dust. So when you do long exposure images, you can see this very diffuse cloud-like structure just weaving in and out through the stars. So it's a beautiful object to see. Personal one I can recommend, having seen it on a number of occasions, is the Hercules star cluster, which is designated as M13. So this object consists of approximately 100,000 stars and is at a distance of 25,000 light years from Earth. So, you know, we're not doing too bad here in terms of our distances into space, but it's also located in the constellation of Hercules. So again, I have some handouts at the very end to show you just exactly where to look. But we also have another intriguing form of star cluster. This is an open star cluster known as the Beehive star cluster. So this one is located in the constellation of Cancer, which is the Crab. No, not Taurus, but we're looking in Cancer, the Crab. And is a naked eye targets located 610 light years from Earth, so it's a bit closer, this one, and appears as a small nebulous region of stars resolved using optical and telescopic instruments. So really, for this object, guys, I would use a telescope if it was me, because you can really gain more of a sense of perspective here when observing this object and seeing this loose structure of stars. And I've left the best ones for last, in my personal opinion. Perseus double cluster. It's such a beautiful sight to observe on a very wide in the sky. You train your light onto this fuzzy patch in the constellation of Perseus nearby, and you just see this view through your eyepiece. It is such a magical, mesmerizing experience. I think that's, you know, easy to agree on. But just to go into some details here, this object consists of, funnily enough, 2 open star clusters catalogued as NGC 869 and 884, and also is a bright cluster in the Milky Way galaxy. So this is one of those particular star cluster regions as I talked about earlier. And as I've already mentioned, an amazing view for a telescope. Totally recommend it when it's visible in the night sky, and is located 7,500 light years from Earth. So guys, I think we're getting near to the end now, but this is what I've promised you. This is just a selection of handouts which I've created. There's more of them if you so wish, but just as a takeaway aspect, as a little thank you for you guys attending this event, these are some handouts which you can use when you're looking up on a cold, clear night to observe some of these deep sky objects with your unaided eyes or even with your telescopes. If you guys are interested in any of these handouts, please make sure to email me or let me know in the chat, just so that I know to send them to you. But they're also red torch friendly, so just to make that aware. And for those of you who are beginners, Josh, what are you talking about? What does red torch friendly mean? Basically, astronomers use red torches to preserve their night vision. And so when you use a torch emanating from a red light source, it protects your night vision, but you can also use these deep sky object handouts to see some of these objects too. And you can read up about them as you're looking through them in your eyepieces as well. So please make sure to send me a link in the chat, or even to the email address I sent the Zoom link invitation out onto, and I'll ping them over to you. So it's on all the objects which we've covered tonight, from galaxies to nebulas to star clusters as well. So you're more than happy to use those at your disposal in your free time. So I always like to use some further resources here on what you can use for further reading. And as I was sort of going into my astronomy career then, I used these particular resources. So this one, written by Alan Hall, is called Messier Astrophotography Reference. So even though it's more tailored towards astrophotography, it's a really good resource which is illustrated as well and goes through all of the Messier and NGC deep sky objects. So these are basically the two catalogues which are used to categorize these objects. And it's very concise. I will be, pretty frank here. It's not, very much a beginner book to read because there's just so much information to read. But one which I can relate more to for the beginner is one written by Warren H. Finley, which is called Concise Catalogue of Deep Sky Objects. And this is a really good resource, guys. It's got fully illustrated color images and, it's exciting to look at. That's how I got into it myself, is through color, really. But it just highlights and goes through all of these objects. So if there's any you want to look at, if you take any interest in, you can relate to this resource and you can observe those and find them in the night sky. Just to mention in the mix as well, guys, if you guys have any any star charts, any planispheres as well, they'll highlight some of the location of these deep sky objects too. So you've also got that as a resource. What I like to use as well is Hubble's Messier catalogue. Not only is it full of pretty pictures, but you get a pretty scientific view, or very well illustrated view rather, of some of these objects that I've covered tonight. They're really good to look at. They tell you where to look in the night sky, what time of year to observe as well. So all of these are very important if you want to have your go at trying to look for these objects. I also have at your disposal some videos which you can watch on YouTube during these weird, strange virtual times at Space4All UK, and also on my YouTube channel, Josh Jury Photo Media, which are basically beginners videos on how to observe the night sky. So even though, like, for example, in this top right image, Ursa Major and Ursa Minor, I also locate how you can find examples or further examples of deep sky objects, but also how you can find different objects like Orion, which we've covered tonight, black holes, and even the Andromeda Galaxy M31. So make sure to check those out. Also, please make sure to follow us on our social media as well. This is the way that this organization is going to work, guys, is through word of mouth. If you guys know anybody who has any interest in the basics of astronomy, stargazing, setting up telescopes, taking images of the night sky, please make sure to drop them a line into Space4All. That's what I'm here to do with the organization, is to get as many of you guys excited and invigorated to look up to the night sky. So if you know anybody, if you want to continue your journey with us, then make sure to follow us on our social media channels, as well as our mailing lists that we send out every now and then at Space4All UK on Twitter, Facebook, and Instagram, also YouTube as well. And just for those of you who are new as well, and to regular members as well, this is our virtual calendar, which we're hosting throughout the year. So we've been starting these events all the way back since last year, but these are some of the subjects which we've covered already. So we're in April now, at the end of April. So we've been looking at deep sky objects. So in our next event in May, we're going to be looking at celestial events. So what is meant by that? For me, some very exciting events like eclipses, transits, meteor showers, so I love these sorts of things. So it's just something to keep your eyes peeled for. But that will be taking place on Thursday, the 27th of May. For those of you who are aware, we have a partial solar eclipse coming up in June. So just to bear on with that one, some very exciting news, where from the UK, we can see our first partial solar eclipse, I believe, since 2015, because that was one of the first eclipses I observed as well. So it'd be lovely to see another solar eclipse from here in the UK. So guys, I invite you now to unmute yourselves. So thank you for being so patient for unmuting yourselves and being so, great with that. I do appreciate it. If anybody has any questions, please make sure to, let me know. If you want to shout out at all, say, hey, Josh, what were you talking about there? Anything. And I will also check the chat tool now. So I'll stop sharing my screen and go back to here, just in case anybody has some questions, which we do. Thank you very much, guys. So here's one from Steve Green. So a question here: how does the numbering and letter of orifix work? Does the latter tell us as to what type of object it is and who names them? Very interesting, Steve. I'm not actually too sure what is meant by orifix, actually, now you say. But if it's in relation to things like Messier objects, deep sky objects, that's how the likes of astronomers such as Charles Messier literally counted them in the night sky. So that was how it was catalogued and how we now know it as astronomers and how we know where the relative positions of these deep sky objects are. So I hope that's helped, Steve. If you can just clarify that a bit better for me, that'd be much appreciated. Jackie Baker, I will send you the handouts and make sure to copy the chat just so that I don't forget to do that. Phil, exactly the same for you. Brian Sherlow as well, I'll do exactly the same. A question from Phil, good friend Phil. So where did the question go? Where are all deep sky object images in your presentation from Hubble? So they're all sourced from NASA, Phil, just for your personal reference. There's some of the best views that we have of these objects. So if you literally type in NASA deep sky objects, they will just flood in. You'll see web pages for it. So you're more than welcome to take a look. Kevin, not a problem. And that's what I'm here to do, Kevin. Thank you for your time. I'll also email you the handouts too. Brian Sherlow again, question, are the previous sessions available to watch? Yes, they are, because you can watch them on my YouTube channel, Josh Jury Photo Media, but I still yet have to transfer them onto YouTube. It's a bit of a tricky sort of one-man show at the minute, but once we've got Space4All much more elaborated and much more expanded, and we've got a committee working together, then we can all share priorities and things will happen much quicker. So I appreciate you guys' time and patience here. And just to say also, thank you very much for all your lovely comments, and really lovely ones to see, very positive. So, you know, I'll shut up now because I'm sure you guys have, you know, been listening to me for nearly an hour now. Have you guys got any questions? Please shout now. Anybody at all? Are you guys completely mind blown?
Yeah. Yes, yeah.
So in I can see you guys on my screen. Hello. Yeah, it's mind-blowing stuff. Like when I first learned about this stuff, you know, I was mesmerized purely by the images which you saw of these objects. That's what first captivated me. And you know, I think a lot of it was down to really my prior knowledge of science fiction films relating to the planet Mars and being encapsulated by those images to look further into the cosmos as well. So yeah, no, it's you know, really about your own astronomical venture. For me, astronomy is for everybody. Like, you know, it's for the young and mature audiences as well. And it's somewhere that we can all share in our sense of place in the universe, and we can all observe these same objects together. So I'm really glad that you guys have enjoyed this talk as well. Martin, just to also mention as well, if you're still in the chat, very interesting presentation. Thanks, Josh. I'd like a copy of the handouts too, please. It sounds like I'm going to be quite busy on email sending out these handouts tonight, which should be a good bit of fun. But honestly, guys, you can use them if you've got like a digital device like your phone, your iPad, or anything like that. You can use it digitally, look up at the night sky, and honestly, it's really stunning, you know, just to look at these objects, learn how to find them, observe this fragile starlight, and there you are. You see these beautiful images of NASA in front of you, and then you can, you know, just relate to really what it is you're seeing. Something else which is just important to address in the mix as well, and I should have mentioned earlier in the presentation actually, but don't expect for 1 minute to observe the likes of Hubble images through your telescopes. That is so important to highlight on, because these images from the Hubble Space Telescope, you know, they're imaging not only with a really wide aperture telescope, but, you know, so many hours of light and long exposure images have been gathered for these deep sky objects, and that results basically some of the best views that we have in human existence of these objects. So don't expect for 1 minute to see the same amount of detail, but more like if you expect to see a fuzzy patch, if you can begin to make out some of the structure and the spiral arms of these galaxies, nebulas, a little faint patch of star clusters, and see a few stars dotted around, that's also very important to mention as well. So just to mention that in the mix too, guys, just not to get your hopes up too much. But if you use much larger equipment, like me and my friends who are in on the chat have done, you use larger instruments and you can actually begin to see more of the structure and some of the color coming through. I can relate that specifically to the Horsehead Nebula. I've used telescopes which are about 20 inches in diameter, sorry. And when you use these telescopes, you can actually see some of this pink color beginning to come through. You can see the silhouette of the horse's head. And honestly, it's really stunning to see. So, you know, just sharing some astronomical ventures there as well. So, yeah, that's just me sharing with a couple of thoughts there from my astronomical journey. Does anybody have any questions since I've been wittering on there? Does anyone have anything they'd like to make a comment on or say? No, nobody? Okay, not a problem. Well, look, listen, guys, we're nearing to 8 o'clock. We're going to finish off at 8. So again, I just want to say thank you so much for supporting me, guys. Thank you for all the lovely comments. It's lovely to see all of your faces again. Thank you for making the time to come to tonight's presentation. So as I've mentioned then, tune in next month for celestial objects and celestial events rather, sorry. And we'll be taking a look at eclipses, transits, and so much more. So as always, guys, I like to wish you guys clear skies and all the best. So I will stop the recording now, and I'd like to say thank you for everybody for watching, and I hope to see you guys next month. So have a lovely evening, and I'll see you all next month. Lovely to see you, and bye for now.
Hi,
Bye.
Josh.
Bye.
Bye-bye.
Bye.